Hello students, let us start today with a new chapter, Carbon and its compounds. Observe these things such as plastic water bottles, steel utensils, pencils, diamonds or fuel used in vehicles such as petrol, diesel and CNG etc. We use them all throughout the day, aren't we? If I ask you what is common to all of them, will you be able to tell me? Do you know that all these substances contain one common element, carbon? Yes, you heard it right. It's carbon. So today we will get information about this very important element, carbon. But in which form carbon is present in them? Let us know. Products like plastics and rubber are made from pure petroleum. And petroleum contains 83 to 87% of carbon combined with 13 to 17% of other elements like hydrogen, nitrogen, oxygen and less than 1% of metals. Since petroleum contains 83 to 87% of carbon, plastics and rubber also contain that much of carbon. Also in steel as an alloy, in which iron, carbon and other elements are mixed in fixed proportions. Steel is also classified into low, medium or high carbon containing steel according to the percentage of carbon atom present in it. The steel utensils and many other such products contain carbon as well. Pure form of carbon, like graphite, is used to get black color in pencil lead. You must be knowing it, I'm sure. The diamond used in a ring or a necklace is also a pure form of carbon. Later in this chapter, we will learn about these two forms of carbon in the detail. Then we talked about the fuel used in vehicles, that is petrol, diesel and natural gas. They are mainly composed of compounds of hydrogen and carbon jointly called as hydrocarbons. When we drive any vehicle, the combustion of these hydrocarbons releases one more carbon containing compound, and which is it? Yes, CO2, that is carbon dioxide. Carbon is not only a part of non-living, but also the part of living organisms. But our body is also made up of 18% of carbon. Various molecules like glucose, proteins, etc. in our body contain carbon. Isn't it amazing? Yes, it is. Carbon is not only the part of non-living, but also a major part of living. An important source of energy that we eat are carbohydrates, and the main element in carbohydrates is carbon, along with hydrogen and oxygen. Thus, carbon is a very useful non-metallic element present in all living and non-living things around us. You may be surprised to know that even though carbon being so important and useful, its percentage in Earth's crust is very low. And do you know how much? The Earth's crust contains only 0.02% of carbon in the form of minerals. These minerals are present in the form of carbonates, hydrogen carbonates, coal and petroleum. And in atmosphere, it is present mainly in the form of carbon dioxide, which is around 0.03%, and very little of carbon monoxide. Thus, despite the availability of such a small amount of carbon in nature, it is very important and inevitable to us. Now, reason to this statement of ours is our previous video. The carbon element is present in nature mainly in two forms, crystalline form and amorphous form. In crystalline form, carbon atoms are arranged in a particular order or in a fixed shape. For example, diamond, graphite and fullerene are crystalline forms of carbon. Do you know that fullerenes are family of carbon compounds in which carbon atoms are arranged in specific shape? While in amorphous form, carbon atoms have no definite arrangement or any particular shape. For example, coal, charcoal, coke, etc. Now you can observe here, students, that diamond, graphite and fullerene have specific shape. The shape of these structures will always be like this. While if you observe coal, charcoal, coke, they don't have any fixed shape. Their shape will change every time with every piece. Both of these forms of carbon are called as allotropes of carbon. Now you will be wondering, what are allotropes? Allotropes can be defined as follows. Two or more forms of any element that exists independently due to the different arrangement of atoms are called allotropic forms of that element. Since their shape, size and texture are different, they have different physical properties. But students note that they will always have similar chemical properties. Students, can you guess a reason for this? Absolutely right. In these allotropes, only the arrangement of atoms change, so that their structure, that is size and shape, change. But no new atom is added or removed to that element, or no chemical reaction takes place, and hence they have different physical properties indeed, but have the same chemical properties. In the next video, we will get detailed information about different forms of carbon, that is allotropes of carbon.